Okay, so in this problem, we're going to figure out the currents. So we need to know the currents, and we're going to use Kirchhoff's current voltage, loop law, and the node rule. So let's look at the node rule first. What we can do is look at the arrows of the current, and we know that whatever current goes into a node has to come out. So if I look at these two arrows, they're both pointing towards I3. So I'm going to say then that our first equation is going to be I1 plus I2 is equal to I3. So I1 plus I2 equals I3. Okay, so I'm using that one first. And then there are three loops here. So there's the loop where, so the way I think about a loop is if I start here and I call this 0 volts, I'm going to call that 0 volts. And as I go across the battery, when I go from the negative side of the battery to the positive side of the battery, I gain that voltage. So I know that voltage is 50 volts. So I'm gonna do, let's see, I think I'll do this path first. So I'm gonna do this path. All right, so I'm gonna go all the way around here, and I'm not gonna concern myself with the middle because current could go just around the outside path. So I'm gonna call that 2. So that'll give me my second equation. And so 2 is going to be, I'm going to start here, so 0 and then plus 50. So plus 50. So that's plus 50 volts. And now, since this is all about voltage, the next thing that's going to happen is I'm going to drop voltage because current's going this way, right? I'm dropping voltage, so I'm going to be losing voltage or subtracting voltage. So that the voltage here is going to be I1 R1, and R1 is 10 ohms. So I'm going to say minus my R, which is 10 ohms, times I1. And now I keep going on the outside, so the current is going to the right. So that means, hold on one sec. So back, my current's going to the right across R3. My current's going to the right across R3. Sorry about this. Wrong one. Okay, so that's going to be minus I3 R3. So R3 is 30. I3 equals 0. So I started at 0 right here. I add 25, or I add 50 volts. I subtract 10 times I1. I subtract 30 times I3, and I'm back to 0. I'm back connected to the negative side of the battery. So that's the second one, and I'm going to simplify this so I can divide everything through by 10. So I'm going to have 5 minus 10 I1 minus 3 I3 equals 0. Okay, and then let's do one more. Let's do the inside loop here, right? So we're going to call this 3. That's my third equation. So 3 is going to be, I'm going to start the same again. I'm going to go around this loop. So I'm going to say, I'm going to start at 0 volts plus 50. So there's my 50. Now minus I1 R1, so R1's 10, so minus 10 I1. And then I get here, and I'm going down, but my current's going up. So that tells me that that's going to be a plus. So that's plus, and R2 is going to be 5, so plus 5 I2. And now I get here, and I'm going down, right? So I'm going down here. So since I'm going down, that's why I had plus 5 I2. But now when I'm going across E2, I'm going to have, I'm not adding voltage, I'm subtracting voltage because I'm going from positive to negative. So that's going to be minus 25 volts equals 0. So I'm on the other side of this battery, I'm connected to this battery, they're both at 0, so I get back to 0. So it's like going around a loop, right? So I start at 0, plus 50 because I'm going from the negative side to the positive side, minus I1 R1. Because I'm going opposite the current, this is going to be plus I2 R2. And now because I'm going from positive to negative, it's minus 25. So if I simplify this equation, I get 50 minus 25 is 25, minus 10 I1 plus 5 I2 equals 0. And I'm going to simplify, so I'm going to divide everything by 5. So I'm going to get 5 minus 2I1 plus I2 equals 0. Okay, so let's take equation 1 and plug it into equation 2. So we're going to say like 1 and 2 together, 1 and 2. So that's going to be, I'm going to just plug in I3 for I3 in this equation. So I'm going to have 5. So starting with equation 2, 5 minus 10I1, and then minus 3 times I1 plus I2 equals 0. So what I'm going to do is I'm just going to come up with an equation in terms of just I1 and I2, and then I'll use 3 in the sum of these. So let's work that out. So 5 minus 10I1 minus 3, let's see, minus 3I1 minus 3I2 equals 0. So something's not quite right here. Let's see. Why do I have 10? Right here. So notice in equation 2, I did this wrong, right? I didn't divide by 10. So this would just be I1. That it'll erase for me, maybe. There we go. All right, so here, right here, and here. All right, so what did I forget? I just forgot here to divide by 10. All right, so now I think that looks right. So I've got 5 minus 4I1 minus 3I2 equals 0. Okay, and so next what I'm going to do is I'm going to rewrite this. So rewrite 3 as in terms of just solve for I2. So we're going to say I2 is equal to, so if I bring I2, or if I leave I2 here and I bring these both to the other side, I'm going to have a minus 5 and a plus 2I1. And then what I want to do is I'm going to use this equation, this new one that I created right here, and I'm going to plug that into the I2 here. So I'm going to just turn the page, and let's see if I can copy this over. I think I can. Oops. Go back and add a page. Okay, so I'm just going to bring this over here, and then we'll be able to keep going. Okay, so what I'm going to do is, like I said here, I'm going to take this I2 and plug it in. So really I'm combining 1 and 2 and 3 equations, right? So I'm going to have 5 starting right here. I'm going to have 5 minus 4I1 minus 3, and now I'm plugging in I2, which is minus 5 plus 2I1 equals 0. And now I can solve for I1. So I get I1, I should get a number for it. So if I have here 5 minus 4I1 plus 15, let's make sure my number is right there. Yep, plus 15 minus 6I2, or I1, sorry, this is a 1, equals 0. So now 5 plus 15 is 20, and minus 4 minus 6 is minus 10, equals 0. Right, so I'm going to have 10I1 equals 20. And when I divide by 10, I'm going to have I1 is equal to 2 amps. Great. So there we go. There's our first answer. And now I can go back and I can go to look at number 3 here. So let's go look at 3. 3 tells me that I2 is equal to minus 5 plus 2I1. So I can plug in for that. So I2 is equal to minus 5 plus 2 times 2. I'll just erase this a little bit. Maybe it'll let me. Huh. Anyway, I think you can see that that's a minus. Okay, so that tells me then I2 is equal to, so minus 5 plus 4 is a minus 1 amp. And then we can see if we go back to equation 1, we can plug in I1 and I2. So we get I3 is equal to I1 plus I2. And so that's equal to, so I3 is equal to 2 plus minus 1. And so I3 is equal to 1 amp. Okay, and now like thinking about our what does this mean? So I2 is equal to a negative 1. I1 is equal to 2, and then I3 is equal to 1. So looking here, that means that when I2 is equal to a negative value, that means that the current direction was wrong. So if we get a negative value, then actually the current is going down. So it's going down to pointing the other way. So it should be pointing, let's see if I can, it should really be pointing this way, going down. And does that make sense? So if I had so 2 amps is, I1 is equal to 2 amps, and then it splits 1 amp down and 1 amp to the right. So 1 amp goes down the middle channel and 1 amp goes to the right channel, so that makes sense. The currents add, so that's terrific. So that makes sense. Let's do, add another page, and we'll figure out B, which is find the power dissipated in each resistor. Okay, so the power dissipated in each resistor. So we'll just call this PR1. And the power is just, it's a couple of things. So power is either IV, so P equals IV, and we'll use that for the batteries. But it's also equal to I squared R. And that's the one we're going to use for the resistors. So I've got PR is going to be I1 squared R1. And so that's going to equal, I1 is 2 amps squared times R1 is 10 ohms. And so that's 2 times 2 is 4, times 10 is 40. So 40 watts. Using the same equation for R2, P of R2 is going to be, so I is going to be 1 amp squared times 5 ohms. And so that's going to be equal to 5 watts. And PR3, I is going to equal 1 amp squared times 30 ohms. So that's going to be 30 watts. So those are our resistors. And now the next one, part C, so this was part B. Let's see, B. Part C is find the power delivered to or by each battery. And so you have to say delivered to or delivered by, and show which battery is being charged. So here we're going to use the equation P is equal to IV. Oh, it doesn't look right at all. Let's see, P equals IV. So P of E1 is equal to the current through I1, through battery 1 is just I1. So it's going to be 2 times the voltage, which is 50. And so that's going to be 100 watts. And now P going through E2 is I2, which is 1 amp, times 25 volts, which is equal to 25 watts. And now, delivered to or delivered by for each. So we're going to say that this is delivered by, and this one is going to be delivered to. And if you think about it, looking at the picture, right, the current is going out of E1, so it's delivering to something, and the current's going into E2, so it's being, current is going, or the power is going into E2 and coming out of E1. So that's why E1 is delivered, this is the amount of power delivered by E1, and then this is the amount of power delivered to E2. And which battery is being charged? So E2 is being charged. So E2 is being charged. Okay, and now D. What happens if E1 switches to 5 volts? So we're going to start on a new page here. And we're going to start over with our equations, right? So we're going to go back and do the same thing that we did before, thinking about, let's see if I can go back here and grab another screenshot here. Add it. Right, so we're going to now, instead of this being 50, we're going to say this is 5. And we're going to start our equations again. So our first equation is going to be the same. So I3 is equal to I1 plus I2. Our next equation, right, that's the current, that's the node law for this node. Now 2, we're going to start with the outside loop, so we're going to go around like this. And so that's going to start with, we start here at 0, and then we're going to increase by 5, minus 10 I1, minus 30 I3 equals 0. And the next one we're going to do, so this is 2, and this is going to be 3. We're just going to go in there, so that's 3. So 3 is going, so let's simplify this, is going to be 1 minus 2 I1 minus 6 I3 equals 0. All right, now 3 is going to be 5 minus 10 I1 plus 5 I2 minus 25 equals 0. So 5 minus 25 is minus 20, minus 10 I1 plus 5 I2 equals 0. And now we can simplify, we can factor, so this is going to be minus 4 minus 2 I1 plus 5 plus I2 equals 0. I'm going to check my notes just to make sure. 5, let's see, 4. Right, so here I'm going to write I2 in terms of, so I'm going to rewrite this to say I2 is equal to 4 plus 2 I1. I'm going to take 1 and 2 and put them together. And I'm going to substitute in I3 right here in 2. So I'm going to say 1 minus 2 I1 minus 6 times I1 plus I2 equals 0. Work that out, so we'll get 1 minus 2 I1 minus 6 I1 minus 6 I2 equals 0. So that gives us 1 minus 8 I1 minus 6I2 equals 0. Let's see. And so now I can plug in this I2 from 3. I can plug this one in to this equation. So I'm going to have 1. So adding in 3 here, plug in. So we're going to get 1 minus 8I1 minus 6 times 4 plus 2I1. Now I'll have just this equation in terms of I1 and I can solve for it. So I'm going to have 1 minus 8I1 minus 24 minus 12I1 equals 0. So that gives us 1 minus 24 is minus 23. And minus 8 minus 12 gives us minus 20I1 equals 0. And so solving for this, I'm going to have I1 is equal to 23 over 20 amps, which is equal to 1.15. And by the way, I'm forgetting the negative sign, so I'll fix that in a second. This is a negative. This is a negative. Right, so there's our first number. So I'm going to add a page. First I'm going to copy everything here. Oops. Add a page. Let's see if I delete all of this. And then select all, move this over. Okay, so now we can plug our I1 into I2. So now we can use this equation, the equation from 3. And we're going to have I2 is equal to 4 minus 2 times I1, which is negative 1.15. And so when we plug this in, sorry, this should be plus. There we go. I2 is going to equal 1.7 amps. And then to find I3, so I3 we go back to equation 1, and I3 is going to equal I1 plus I2, which is negative 1.15. Go a little slower. Negative 1.15 plus 1.7. So I3 is going to equal 0.55 amps. So there you have part D. And is the direction correct? So if we look at I1, we know I1 is in the negative direction. So if we look at our picture here, whoops. If we look at our picture here, then we see if I1 is negative, that means I1 is going to be going to the left. So we have I3 is positive and I2 is positive. So so we're going to have our current in I1 going to the left and our current in I3 and I2 going, let's see, in the way that's shown. So I2 is going to be pointing up. Right, so I'm going to be delivering. So this battery is going to has more voltage, so it's going to be the one that's delivering power to these others. So this one's going to be going, I2 is up, I1 now is going this way, and I3 is going this way. And that makes sense, right? I2 is 1.7 minus, so 1.7, and then this is going to the left, so 0.55 plus 1.7 would give us that. So we can also tell here that E2, battery E2 is delivering the power. So it's providing the power and it's charging E1. So bonus question is, for the new E1 in part D, find the power delivered by each battery. So let's do the bonus. So the power delivered by E1 now is going to equal the current, which is 1.15, times the voltage, which is 5. And that is, the answer for that is 5.75. And PE2, do the same thing, is going to be 25, or sorry, yeah, 25, let's go back. So it's going to be 1.7 amps times 25 volts, which is going to be 42.5 watts. So this is going to be delivered to, this is going to be delivered by E2 is charging E1. And they want to know the power delivered to each resistor. So that's the same that we did before. So PR1. This time we're going to use I squared R. So this is going to be equals, so 1 is, let's see, 1.15 squared times 5. And that's equal to, or sorry, times 10. 1. And that's going to equal 13.2. PR2. I squared is going to be 1.7 times 5. And that's going to be, so this is I squared R, so 10 ohms. This is 5 ohms. This now is 14.5 watts. And PR3 equals 0.55 squared times 30. And so that's going to equal 9.1 watts. And that's it.